Hello my dear students, so welcome back to the St. Joseph Composite PU College, Vijaypur. I'm Rahul, chemistry faculty, and in this video I'm going to discuss the osmosis. Very important and very beautiful concept. Let's understand that what is osmosis. I just want to explain you that why osmosis occurs. Many times when you read the books, you don't get that why osmosis occurs. You will get only the definition. My point of way of teaching or explaining is why the things happens. Thing happen here, that is osmosis. Why is it occurring? Okay, let's understand that. So this explanations includes very simple experiment or simple demonstration. Is that you just visualize this. Okay, if I have a certain container here, this is a type of container. You can notice here. This is a metal container or something. Container is there, and this container I divide it into two parts. Okay, there are two parts are there. Okay, now I will fill water in this. This is the level of the water. You can see that. Now this partition is this is done by the semi-permeable membrane. Semi-permeable membrane. Semi-permeable membrane. Now what it do? It allows only the solid molecule to pass through that, not the solute particles. But right now there is only water molecules are there. Now let me take here H2O, and here also there is a H2O is there. And now these are the number of molecules. You can see that 1, 2, 3, 4, 5, 6, 7, 8 number of molecules are there. Let me write the same number of molecules on the other side. This is 1, 2, 3, 4, 5, 6, 7, 8 number of molecules are there, right? The number of water molecules at the surface that are equal. Their operation is also equal, right? Their operation is directly depends upon the how many number of water molecules or the solid molecules are there at the surface. Okay, that is the actual fact, students. Now assume that there are 8 number of molecules are there. Let's take here 4 molecules get evaporated out, and here also the 4 molecules get evaporated out, and these 4 molecules collide with the wall of container and also collide with the surface and producing the force per unit area called as pressure, and that pressure itself called as a vapor pressure, students. That pressure is called as vapor pressure. Now the point is, so why I'm talking all these things about the osmosis? Why I'm talking about vapor pressure? Yes, the osmosis is happening due to the vapor pressure, students. Let me relate it. Now what happens here? Now in both the compartment, let me take here P1, the pressure 1, and is the pressure 2. Both the compartment contain same number of vapor molecules, and therefore there is a same vapor pressure. Now what I will do that? In the second compartment, I will add sodium chloride, NaCl, and this is a non-volatile solute, students. Okay, it never get evaporate very easily at normal room temperature, and some of the sodium chloride particles get accumulated at the surface. So these whatever the lines I am drawing here, these are the particles of sodium chloride. Now you can see that the number of molecules at the surface get reduced, right? That's the number of water molecules at the surface. 1, 2, 3, 4, 5. Let me erase them here. Now what happened? Here the 4 vapor molecules are there, only here 3 vapor molecules are there. Therefore the P1 is greater here, right? The vapor pressure here it is more and here it is less. And because of that, what happens? This vapor pressure push the solid molecules downwards, and by that the solid molecules they move to the other compartment. Now taking in the consideration of concentration, this compartment which do not contain any sodium chloride, that is called as a low concentration. Okay, and this compartment which contains the sodium chloride, it is called as a high concentration. Okay, so therefore we can define here the osmosis, the process in which the movement of solid molecules from low concentration to high concentration through semi-permeable membrane is called as osmosis. Okay, this is the fact. But why osmosis is occurring? Osmosis is occurring due to in pure solvent or in the low concentration solutions, the surface contains more number of solid molecules, more vaporization, more vapor pressure, and by that the solid molecules are pushed downwards and they move towards the higher concentration, right? So when we define the osmosis, we take the consideration of non-volatile solute concentration, students. Many of the students seen that they talk about the concentration of water. It is not. We always think about the concentration of sodium chloride. Many times when I visited for some of the interviews, the students or even the teachers interacted me thinking that water concentration we have to take. No, we have to take the concentration of a solute. Okay, not the solvent. Okay, this is one part. Now looking at this point, we will derive the equation here. One simple equation we will find out. So as we know that the ideal gas equation, the well-known, very famous ideal gas equation, which is not corrected by van der Waals, that ideal gas we have to take here and apply the osmosis. Okay, what do we have here? The PV is equal to nRT. The PV is equal to nRT. Where the P is a pressure, V is a volume, N is the number of moles, R is the ideal gas constant, T is absolute temperature. Okay, now what I will do that, I will take one point here. Instead, this equation is, this is applicable for only the gas molecules, and that to ideal gas molecules. But we can apply this equation for dilute solutions also. Okay, by replacing P in terms of pi here. The pi is a new term. The pi is called as osmotic pressure. Osmotic pressure. Okay. Then what is osmotic pressure? Let me explain you with the same experiment for it. We'll take the same container, and here is a partition, water level. Okay, so now this is low concentration zone, low concentration, and it is high concentration. Okay, now at high concentration zone we applied with the piston. We arrange some instrument here, we have to push it downwards. Now as we know that here we have high pressure and it is a low pressure, the solvent molecules are moving from low concentration to high concentration. This is a phenomena that I just explained. Now what I will do that I will put a force on this piston, and by that the piston moved downwards. As it moved downwards, the pressure increased here. When the pressure in the high concentration solution is increased, the movement of solvent molecule from low concentration to high concentration ceases, it gets stopped. Okay, and that pressure is known as, whatever the pressure you applied here, the pi extra pressure is applied here, that extra pressure is called as a osmotic pressure. What is osmotic pressure? It's a pressure which is applied on the solutions or high concentration solutions, which stop the flow of solvent molecules from low concentration to high concentration through semi-permeable membrane. Okay, that is the osmotic pressure, friends. Hope you understood this. This is not needed, just let me explain this part. Okay, now go to the next. Pi is osmotic pressure. So therefore pi is equal to N by V RT. Okay, RT it is, RT, where N by V is concentration. N by V is called as concentration for it. Now what we'll do that, pi is equal to CRT is the equation we can use for the calculation of osmotic pressure. Now we'll take again this equation. Now what I'll do that, pi is equal to number of moles can be calculated. Assume that B is a solute, B is a solute. So in that case, WB is the weight of the solute we taken, and that should be divided by molecular mass of the solute B. And these two terms give us number of moles, and divided by the volume of the solvent we taken. Okay, so the volume we can take here V RT. So then we can simplify it. Pi is equal to WB RT divided by MB into V we have. Now I want to calculate the molecular mass of the solute using osmotic pressure. If I know the osmotic pressure, then what I will do that, this implies here something very interesting, that MB is equal to WB RT whole divided by what we have here, MB is taken here, right? So instead of that, what I will write, pi into V. This is the equation we use for the calculation of molecular mass of the solute using osmotic pressure, friends. Very interesting it is. We'll see some of the problems in the next video, students. Thank you for watching this, students.